Hello, this video is to record section 8.1, and I'm going to do it in two parts. Section 8.1, this lesson will teach me to write polynomials in standard form, name polynomials by degree and number of terms, and part 2 of the video will go over adding and subtracting polynomials. The next slide is not in your notes, but go ahead and take a quick peek at it with me. It says identify the meaning of the following prefixes. We know mono to be 1, bi meaning 2, tri meaning 3. And when I ask my students usually what does poly mean, most of them shut out 4. Instead of thinking 4, think about it as 3 or more, or in this case, we're going to write many. The next thing says, the following are examples of like terms, true or false. In part 2 of the video, we will be combining like terms, so I want to take a moment to discuss with you what are like terms. So look at 2a, 3x and negative 2x. These are like terms. I'm going to go over here to letter B. 8x and 7y, these are not like terms. Letter C, negative 5x squared and 9x squared, these are like terms. Letter D, these are not like terms. Letter E, like terms. Letter F, unlike terms. Letter G, these are like terms. And letter H, these are unlike terms. So what makes like terms like terms? Like terms are when you have the exact same variables and their exponents. So they have to have the same variable with the exact same exponent. So letter H is false because here is an x squared, and in the second part, there's a y squared. Letter G, they are like terms. The letter or the numbers in front don't matter, but I have an x squared, a y to the third, x squared, and a y to the third. On to your notes. All right, get all this out of the way. Your notes ask you to define monomial and give examples. A monomial is a number, a variable, or the product of a number and variable with whole number exponents. A monomial is a term. Think of a term as a group. It's a thing. It's one piece. So some examples. An example of a number. 5. 5 is a monomial. 6 is a monomial. A million is a monomial because it's a single number. A variable, an example of a variable. X, Y, Z, A, B, any variable. The product of a number and variable. Well, product means multiplication. So the example of a product of a number and a variable could be 5x. It also could have exponents. 5x squared, 5x squared y. All of these would be examples of monomials because there is one piece. It is held together with multiplication or it is one standalone chunk. However, some things that are not examples. If I did 5x minus 3, this is not a monomial because we now have two pieces. That would be referred to as a binomial. Another example of something that would not be a monomial. 5x squared plus 2x minus 3. This would be referred to as a trinomial because it has 3 distinct pieces. One other non-example would be something where the x is in the denominator. This is not a product, this is a quotient here. Think about a quotient as division. So again, that is not going to be an example. And while I talk about product, another example, I can have multiplication. I can call it x over 3. These things are the same because it's 1/3 times x, a number times a variable. But this particular one is saying 3 divided by x. And because this is quotient, it's not a monomial. It's not a binomial. It's not an anything omial. We have a couple of definitions. In your packet, under number 2, it says complete the chart, and it says define terms. You're going to use those large boxes above those headers to put in some definitions. So when it says define terms, I actually want you to know that a term, and I know it says define terms, but when it talks about terms as well mathematically, a term is a monomial. And monomials are the examples up above. When we talk about standard form, a standard form of a polynomial is how you're going to order it. You're going to order the terms alphabetically by highest exponent to lowest exponent. And when we talk about the exponent, we're looking at the exponent on the variables. When we talk about the degree of a polynomial, the degree will be the highest exponent you see. A monomial, a binomial, a trinomial, or a polynomial is based on number of terms. So the example that I'm circling in red is a binomial because it has 2 monomials. It has 2 terms. And when we name a polynomial, we're going to name it based on its degree, so whatever is in this column, and based on its number of terms, whatever is in this column. It's going to have a first name and a last name. Before I go on to the chart, let me give you a couple of examples. I'm making these up as I go, so they're not in your notes. When we talk about standard form, you're looking at the degrees. You're looking at the exponents on the variable. Which of these terms, I'm going to put the first term in red and the second term in green. Which one of them has the variable with the highest exponent? The 8 is a higher exponent than a 3. So when we talk about standard form, you're going to reorder these 2 monomials, referring to them as a binomial, meaning 2, so that the one with the highest exponent comes first. The 7 is a positive. Notice it's a positive up here. The 6 is a positive. Notice that it's a positive. Let me give you another example before we move on to the table in the notes. There are 3 terms. This is a trinomial. I have a term here, a term here, and a term here. It is made up of 3 distinct pieces. Which one of those pieces has the highest exponent? It comes first. Notice it's a positive 7, or it's a positive 1x, so 7x to the 7th is coming first. Which one has the next highest degree? Next highest exponent? Notice it's a positive value. And then for this middle term that I have circled in blue, what is the exponent on the variable? Because I don't see 1, it's a 1. Careful that this is a -6, so when you rearrange it, the sign goes with it. All right, let's look at the table now. So the first one asks you to put it in standard form. There really isn't anything other than 3. You can't rearrange 3 another way. So a standard form is just 3. I have written here that you don't need what is being circled in red, but there really is an x to the 0 power because we know that anything to the 0 power is 1, and 3 times 1 is 3. When we talk about the degree, we're looking at the highest exponent. Well, the only variable with an exponent is x to the 0, so it has a degree of 0, which we refer as constant. Is it a monomial, a binomial, or a trinomial, or a polynomial? Because it has 1 piece, it is a monomial, so its name is a constant monomial. Letter B, it's a monomial. There's 1 piece. There's no way to rearrange it, so I'm simply going to write 5x. its degree is the highest variable exponent. It can't be a 0 because the x is present, so x is an exponent of 1. 1 we refer to as linear. It is a monomial, so its full name is a linear monomial. Letter B. Letter B has two distinct pieces. We have a 6x and a negative 7, which is why it's referred to as a binomial. Thinking about the exponents, there's an exponent of 1 here, and we don't need to write it, but there's really an exponent of 0. It is in standard form because the highest exponent and then the lowest exponent. Anything with a degree of 1 we call linear, linear binomial. Letter C. Letter C has three distinct pieces, 1, 2, 3, which is why it's referred to as a trinomial. The exponents need to go in order from highest to lowest. So the term with the exponent of 2 comes first. Make sure that it's a negative 5. The one with an exponent of 1 comes next. And then that has an exponent of 0 comes next. You do not need to place those on there, but that's why it's in standard form, because I have an exponent of 2, exponent of 1, exponent of none. Because its highest degree, its highest exponent is a 2, we call it quadratic. And we've graphed quadratic equations before. So its full name is a quadratic trinomial. Letter D, two distinct parts. That with the highest exponent comes first. That with the next highest exponent goes next. Keep in mind, though, that it is a minus x, which is why it's a minus x to the first. It has a degree of 2, which we refer to as quadratic. It's a quadratic binomial. Take a second, pause the video, and fill in the rest of your chart. Here are the answers. How'd you do? For letter E, this is the first time that I've spoken of the idea of polynomial because it has more than 3 parts. With a highest degree of 3, we refer to 3 degree of 3. You wouldn't have known this before I paused it, but it's called cubic. Well, maybe you would have. We talked about it with functions. This is a cubic polynomial. Letter F. Letter F is kind of a trickster because we have like terms. I combined those like terms, which made it still cubic because it has a degree of 3, but it now only has 2 pieces. Letter G. If you put it in order from highest to lowest, the negative 2x to the 9th comes first, and the 7x to the 5th comes second. Its degrees, its highest exponent is a 9, and we're actually going to call anything with any degree larger than 3, call it by, I'm going to use letter n, so nth degree. And n is to be replaced with any value that you have. So because this had a value of 9, it's a 9th degree. It has 2 pieces, so it's a binomial. Lastly, letter H, and this is the hardest one. It's as hard as it's going to get. It has 1 piece. It is referred to as a monomial. But when I look at its degree, a lot of you are going to want to call it 3 because its highest value is 3. But the trick here is that it's 1 piece. It's not 2 separate pieces where you say, okay, this is the highest. This is 1 term held together by multiplication, a single monomial. So when you find the degree of a monomial, what you're really doing is adding the exponents. And I use this analogy, and it's not perfect, but if you think about anybody with siblings and you were to ask your mom, like, Mom, who do you love better, my brother or my sister? She's going to say, I love you all the same. You're all so fabulous. You're all my children. Same thing here. This is 1 piece. So you can't say that the 3 is higher than the 2 because it's all 1 chunk. So that's why we add it together, call it a 5th degree monomial. Good luck. Ask questions if you have them.